Assalamualaikum and hello everyone. Today our group will present our results for the experiment 4, which is linear motion. Next up, this is the introduction for our member of the group. Next, the objective. The first one is to investigate the relationship between force, mass and acceleration. The second one to determine the acceleration of an object under a varying force. After that, this is the introduction for linear motion. Linear motion refers to movement along a straight path which is described by parameters like displacement, velocity, and acceleration. This experiment investigates the motion of an object under constant acceleration using a track and timer to analyze its velocity and displacement over time, verifying kinematic equations.
The apparatus for this experiment is a track rail, blower, pressure tube, gliders, flag, photogates, meshes, mesh hanger, string and pulley. This is the schematic diagram of the acceleration system. Procedure for this experiment is assemble the linear A-track set as shown in figure 4.3. Second, switch on the pump and let the air blow through the track for several minutes. Balance the track by adjusting the screws on the leg of the track. Third, insert one hook and one end and a flag on top of the glider. 4. Measure and record the mass of the hanger and mass of the glider. Attach one end of the string to the hanger and the other end to the glider. Place meshes with a mass of 20.0 gram on the hanger and 80 gram on the glider. Put the string over the pulley. Position the glider exactly before the photogate. Release the glider and record the time shown on the photogate. Note: in order to avoid meshes from crashing to the floor and scattering, catch the glider with your hand before the hanger reaches the floor. Repeat 2 more times to obtain the average values. Then, decrease the slotted mass on the glider by transferring a mass of 20 gram on the hanger. Repeat step number 7 and 8. Repeat the procedure 3 more times with 20 gram from the slotted mass on the glider added to the hanger. Repeat the procedure 3 more times with 20 gram from the slotted mass on the glider added to the hanger. So this is our result for this experiment.
Based on the experiment, the acceleration increased as the weight of the hanger and slot mass increased. This demonstrates that acceleration is directly proportional to the force acting on the system and inversely proportional to the mass of the system. From the plot graph, it is evident that the relationship obeys Newton's second law, which states that as the force increases, the acceleration will also increase. Conversely, as the mass increases, the acceleration will decrease. Releasing the glider with varying slot mass shows that the acceleration changes accordingly. Specifically, the time taken for the glider to travel decreases as the mass increases, which aligns with the formula F equals to ma. However, a few sources of error were identified during the experiment. One significant source of error could be friction acting on the glider. Additionally, conducting the experiment on an uneven surface may affect the acceleration. Therefore, it is recommended to conduct the experiment on a flat and smooth surface to minimize these errors.
Conclusion for linear motion experiment is we investigated the principles of linear motion by analyzing the relationship between displacement, velocity, acceleration, and time. The results confirm that an object in uniform motion moves with constant velocity, while an object experiencing constant acceleration follows the kinematic equation of motion by plotting displacement versus time and velocity versus time graph. We observe that the slope of the displacement time graph represents velocity and the slope of the velocity time graph represents acceleration. Any deviations from expected values were likely due to experimental errors such as friction, air resistance, or measurement inaccuracies. Overall, the experiment successfully demonstrated the fundamental concepts of linear motion, reinforcing the mathematical models used to describe motion in physics.